Welcome back. This is going to be Unit 4 of the Hosting Drupal on Kubernetes class. This one's all about configuration. So there's a number of different things about passing configuration that we can do within a containerized environment. We could bake the configuration into an image like the database name, the database user, the database password. We could use environment variables, or we could mount config files into individual containers inside of our pods. So let's look at each one of these. First, we can bake them into the image. This is really straightforward. It comes out of the box. That's what the username is. That's what the password is. That's what the database name is. And that's exactly what we did in the last lab. The problem is that it's limited. It can only change by redeploying the underlying image. So if we need to change the database name or the database password, we're going to have to create a completely new image that has that baked into it. And that might not work if the files already exist. So that's going to be a little bit difficult. Also, this is generally insecure because anybody who downloads the image will immediately know what the password is. And that's not cool. We don't want that. We want to discourage sharing, and we want to make sure that the passwords are unique for every individual application. So what about our second option? Let's use environment variables. This is a stalwart. If we've used this before, we've probably used it with Docker Compose. Some Drupal-specific hosting providers use environment variables to pass this information. The thing is that when it comes to environment variables, they're better for individual values. If you need to pass a complex file, that it's not very good at. Like, say, a certificate file is as big as you really want to ever pass an environment variable. But the most important problem with environment variables is that they are fundamentally insecure. In a Unix environment, there are no user access standards around environment variables. If they're in your environment, you can read them. There is no read or write only. They are a free-for-all. And as a result, they're not really secure, not really a good choice for passing critical pieces of information like a database password or an API key. In those cases, you want to use something that's more secure. So that leaves us with our last option, mounting a config file. It's good for simple and complex config because a small file mounts the same way as a really big file does. It doesn't matter. It's just mounting a file, whatever. It's also secure because in a Unix environment, it's subject to user permissions so that you can deny people from reading or writing to it as needed. So it's generally a good thing. And even better, it's already used by most applications already. Drupal does this, MySQL does this. These are all fairly standard things that we can actually use as a standard mechanism to configure applications. So why do anything different? We could just mount files. So sometimes also we need to very specifically share config. Now I know I just said sharing config is bad, but why are we talking about sharing config now? There are limited cases where you do need to share config. Like where? Well, if we create a database that has a unique database name, a unique database user, and a unique database password, we know that there are two places that needs to be used in. Not only the MySQL server in order to create the database, but also on the Drupal web server so that it can access the database. So sometimes we need to very specifically share configuration in a best practice format, only for key values where needed, and we want to write them once and use it everywhere. So we're not copying and pasting values for Drupal versus MySQL. We want to change it once, it's changed everywhere, it's done. So how do we define configuration and solve these problems in Kubernetes? Well, Kubernetes defines them as a secret. A secret stores config values and small files. It's encrypted by default. So every time that you add a new secret, it's encrypted within Kubernetes and is only decrypted when mounted on a pod for use. Also, these objects are defined separately. They're not part of a deployment or a stateful set. They are their own object. This way, you can actually define them separately, write them once, and reuse them again and again and again throughout your application as necessary. Here's what a secret definition looks like. API version 1, kind equals secret. The name is Drupal-DB. The type, let's not worry about the type. There are multiple types. Most of the ones you'll be using are going to be opaque. There are some types though. I think, I forget. It's a Docker config file is one of those types. But you won't see that in this class. And then there's the data section. And the data section is going to contain one or more files and the content of those files. But you'll notice that the file name here makes sense. It's Drupal DB password.txt. But the file content is a whole bunch of this lettered garbage with an equal sign at the end. What the heck is this? Well, let's talk about that. So the data section defines one or more individual values, and each one of those is mounted as a separate file in the pod. If we go back to the definition really quickly here, you'll notice that there's nothing requiring us to name each data item a file. We can name it whatever we want. I like using file names because it reminds me that when this is mounted in a pod, it becomes its own file. And it just makes it very easy for me to conceptualize that. So that's why I name them after files. But what about that value section? Well, that's because it's base64 encoded. Each data item is base64 encoded within a secret. And this makes creation clumsy because if you create the YAML, you have to encode that before submitting it. Kubernetes will not do that for you. There is actually a way to make Kubernetes do that for you, but only on creation. It's called string data. This assumes values are not base64 encoded within the secret, but they are encoded on save, and then the string data section is removed and becomes a data section afterwards, just like we just saw. Here's what a string data section looks like. Again, it's the same kind of definition for the file that we saw before, but this time, instead of data, we have string data, we have Drupal DB password.txt, and then we actually have the password in plain text. Again, this will only survive on creation of the secret. Afterwards, the string data section is going to be removed, replaced with the data section, and this plain text password will be base64 encoded for us. How do we manage secrets? You already know how to manage secrets. Keep control, get secret, describe secret, edit secret, same commands, same verbs that you're used to. Everything is exactly the same way that you're used to it. So you already know how to do it. Also, when you're using a string data, it's encoded, anytime that you work with a secret, the data is encoded on edit. So values are not going to be base64 decoded for you if you're going to try to edit an existing secret. Instead, everything will be base64 encoded, and the editor doesn't decode it for you. So you can do this in two different ways. You can use a special editor that recognizes that these values are base64 encoded, that you're working with a Kubernetes YAML file, and it will decode them for you. Or you can copy the file, copy the value, base64 decode it, edit it, base64 re-encode it, and then save it onto the file. It's clumsy and difficult and not fun. In general, secrets are better for individual values like a password, an API key, things like that that are direct, that are simple. And it's good for very small files, but the problem is that secrets can't be larger than 1 megabyte. Kubernetes secrets only can be 1 megabyte in total. So as soon as you get over that limitation, secrets become untenable. So we need bigger config. We need to do something bigger because sometimes we may have a file that big. How do we handle that? Kubernetes has us covered here too. It's called a config map. A config map is used for whole files or sets of files and has a much, much larger storage limit. I don't remember what it is offhand, but it keeps seeming to get bigger every time I go and check it. Also, config maps are not ever encrypted or base64 encoded. They are stored plain text within Kubernetes, and you can edit them in plain text all the time. which does not make them suitable for storing passwords or critical things like API keys. They're much easier to edit, but they're a lot less secure. So here's what a config map looks like. It looks remarkably like a secret. API version 1, kind equals config map, metadata name is MySQL in this case. You'll notice that we've been reusing names here and there for like the service definition and the deployment definition, or the stateful set definition and the service definition. In this case, a config map name and a service definition. It doesn't matter because those are different kinds. As long as the kind is different, the names can overlap. They don't imply any relationship though. It's just useful for us to name them the same thing so that we know that they are actually highly related to each other. So like a secret, it has a data section, and in the data section, it has one or more items, and each item is a file. In this case, we have one file, which is called flight-deck-YAML-db.yaml, and then it's got a pipe next to it. Now, this is a YAML thing that Drupal doesn't tend to use. This is a multi-line value, and this the pipe means respect carriage returns, but actualize the rest of this as a single value. So we're putting a YAML file inside of a YAML file inside of Kubernetes. Cool. Okay, how do we work with these config maps? Same way that you've worked with everything else. You can apply them, you can get them, you can edit them, you can describe them, you can delete them. Same kind of operations that you're used to. All right, now that we've defined them, how do we put them to use? Every time you use a secret or a config map, they are mounted as a volume inside of a pod. And instead of referring to a disk or a claim name, you're going to refer to the secret or config map name, not a volume claim name. So let's take a look at our deployment. Here's a deployment for a web deployment. And if we scroll down, we'll notice it has a volume section. And in the volume section, we're going to have vol Drupal DB, and it's going to mount a secret, and the secret name is Drupal DB. Perfect. And that's it. That's everything that we want to do. If we need to mount multiple secrets, we just add another line here and keep going. It's not a problem. So the volume section tells Kubernetes to treat the definition as a disk, and it's defined in the deployment or stateful set definition in order to use the config map or secret. The volume mount section specifies where to mount the volume inside of the pod, usually used by volume claims, secrets, and config maps. So if we look at our stateful set definition, we have a volume section, sure, that's fine. We've seen this before, and it even has a secret in it, vol Drupal DB. But where is this mounted inside of the container? Well, if we scroll down, we'll see there's a volume mount section. And in the volume mount section, we have our persistent claim template, sure, but we also have a mount path for our config map and for our secret, so that this way we can determine where these are mounted inside of them. You'll notice also that these don't refer to the file name within the secret or config map. Instead, it refers to a directory, and that's because each secret or config map can contain multiple files. So it's best practice to assign each one of those its own directory to represent all of the files in that secret or config map. So this creates kind of a problem, though. Config maps are a lot easier to edit. They're great for really big configuration files, but they're terrible for passwords because they're not encrypted. How do we handle that? Well, this is something that I like doing. I like chaining files together. A secret is chained to a config map, and the config map is read by the application. This is not a Kubernetes concept, but it's really obvious to use this. So some config files can include other files, especially sometimes for key values. And this is product and also container specific. So if we look back at our config map, our flight-deck-db container takes a single file as a configuration file, flight-deck-db.yaml. And in its documentation, you can specify the password directly for the MySQL user, or you can specify a password file. And the password file isn't the contents of the password, but a path to another file which contains the password. Again, this is container specific to flight-deck-drupal and instead of a Kubernetes thing or a Drupal thing. This way we can define a secret that is going to be mounted at that same path that has that file in it with the password. And that way the password is encrypted and stored as a secret, and the rest of the configuration file is stored as a config map. That way everything is a lot easier for us to manage. So what about Drupal? We have to configure Drupal too, right? I mean, we could in fact create a config map that has all of settings.local.php in it, and I've seen some people do this, and it has some validity in my opinion, but it can be a bit huge and a bit clunky. But you can chain files very easily to it by actually going in the settings.local.php. You can slurp up a file that's on the file system that contains the password itself. And that would work, and that would actually be an effective way of setting up a settings.local in Kubernetes. But it does introduce a problem. Now, every time Drupal executes, it has to slurp that file up again. You're incurring additional file I/O every individual time you make a request. And this might be a bit of hyper-optimization, but that can slow you down over time. And that's not really cool. Wouldn't it be great if we could do something a little bit more smartly? If we had just some setup process in order to set the password and create the settings.local file for us before the container starts up, then we would be good, right? We wouldn't have to worry about it. And this is where a custom container entry point can actually be a possible option for deploying configuration. Custom entry points are going to be defined on the Docker image itself. So it's a little bit out of scope for this class to describe how that works. But what it does is it allows us to specify a command that will run in place of the normal command that the container represents, say MySQLD or Apache. In this case, we can run additional setup tasks before that command starts up. So this is good because we can make custom startup tasks that can template files, do a whole bunch of other fancy stuff for us, create user accounts, a whole bunch of fascinating, useful, variable things that we can do. And it's really useful for us to do it like that. However, it does require some deeper Docker knowledge. Now, some containers will do this stuff for you, like flight-deck. Heavily makes use of custom container entry points to read YAML-based configuration files to configure each container on startup. So that's something that you can look at. Where we can find an example of this? flight-deck's own examples are kind of complicated, but one of the containers is actually an exception. The 10.7 flight-deck-drupal container, which you've already been using, is in fact an example of a custom container entry point which automatically creates settings.local.php for you out of the box. And you can find the code for this on github.com/7/flight-deck-drupal. So you can find the code on there, you can find the Docker file, and you can find the script files that make up our custom container entry point and see how that works. All right, it's time for the final lab for this class, which is lab 4. In this case, we're going to create a secret and a config map. We're going to update our deployment and stateful set to use the secret and config map, and then we're going to observe how this changes the overall effect on pods. All right, let's go. Last lab, everyone.